Hi, my name is Nicole Bauman, and this is my screencast for Module 2 practices. The question that we were to answer was, what is the best land cover for a healthy watershed? The standard I chose was the roles of water and Earth's surface processes water, continually cycles among land, ocean, and atmosphere via transportation, evaporation, condensation, and crystallization, and precipitation, as well as downhill flows on land. I believe this fit well with the activity because we're looking at different types of soils and which one is best for a healthy watershed. The Imagine step was also given to us. It was recommended that we started by researching runoff with a simulation, which I did, and then one possible way to help us answer the question was through the use of erosion bottles. So for the planning step, the first thing was some questions that I had. What are erosion bottles? So I did look at the activity given to us as well as some other activities that I researched. And then I thought, what will I need to make the bottle? So what materials did I have readily available to me? And then I also was trying to figure out where I'm going to get the soil and the grass needed for the bottles. And one of the activities it recommended that we grow the grass, which that was not possible for me to do. So I was thinking how best to get the grass that was needed for the bottles. So then I made a list of the materials I needed and went around gathering those materials. For my create step, the first thing I did was cut the bottles to have the rectangular shape at the top for the different type of soils to go inside. Then I went around and collected the soil. The first soil I decided to collect was just some dirt with mulch and leaves in it. Then I cut out a piece of grass in our yard. And I really tried hard to make sure that I was going deep enough so that the soil and roots are still intact, because I knew that was an important part to make sure that I was getting the correct soil. And then the last soil I got was the soil from underneath the patch of grass that I collected. That way I made sure that there was no mulch or extra things inside of it. Once I had all of those inside of my bottles, I then poured the water inside and I waited to see for the results. So here's the first setup of the three materials inside. The first one was with the grass and the roots intact. The middle one was just the soil underneath the grass. And then the last one there has the different types of mulch and leaves inside of it. So here's me pouring water into the three different types of soils. As you can see, this one the first one is from the grass. The middle one was from the soil underneath the grass, and then the last one was the mulch with the leaves and sticks inside. And here were my results. You can see that with the grass and the roots intact, it did have the best pour coming from it, whereas the other two still had a lot of dirt coming out with the water. So I was pleasantly surprised with how well the activity worked. Just some things that I would improve on. I thought of measuring out each type of soil to have the same amount going into the bottles. I wasn't sure if that affected the results at all, but I thought it would be a good way to apply math into the activity as well. I also want to use all the same bottles. I don't know if I noted that earlier, but I did have two of the same bottles and then one was a different shape. So again, I wasn't sure if that affected the results, but definitely something to consider. And then I wanted to make it more of a challenge. I know my students are always motivated with a little challenge, so not too sure how I could do that, but definitely thinking about adding kind of a design challenge into it. And then here's where I analyzed using the connections among STEM practices. I felt in the science category we were asking questions. We constructed explanations based off that scientific question. And then I obtained, evaluate, and I'm currently communicating the information gathered through, again, that scientific question that was given to us. In the engineering column, the development and the use of our erosion models. We planned and carried out our investigations, and we analyze and interpret data. For the technology, we used the simulation in the beginning, so I felt like that fit into recognize the role that technology plays in the advancement in science and engineering. And then last, the mathematics column, we used appropriate tools We were reasoning abstractly and quantitatively, and then we looked for and made use of structure. This chart is still something that I'm working with, so I'm really curious to see how everybody else picked out different things inside of here.